Hello and welcome to SudoKanard. We're here to solve this remainder Sudoku by Madhav. This puzzle is taken from round 3 of Sudoku Mahabharat, which happened a few weeks ago at the time I'm doing this video. And during the contest I broke it twice, after which I turned to other puzzles. And after the contest I managed to break it again. I hope I will do better this time. So the special rule is that whenever you have a small digit in a circle, it means that this digit is the remainder when you take the two digits that surround the clue and you divide the greater by the smaller. And so that's basically it. And I have provided the table of remainders that you can see. And something very interesting is that a remainder of 3 and a remainder of 4 are very constrained. And for example, a remainder of 4 means that the digits are 5 and 9. So the same is true here. And the remainder of 3 with the 6, it's necessarily the 9. And this here is a number that divides the 6. So it will have to be 1, 2, or 3. But 1, if you look at the table, you see that 1 is always with a 0, so that's not a 1. And something else is that this has to be an even digit, and this has to be odd, so that's the 3. And if you're looking for an even digit that has 4 ones on its row, you see that only 2 works. And those here must be 5 and 7. This is now 1 or 4, and we have a 1, 4, 8 triple in here. If you're looking for a digit that has at least 4 zeros on its row, you can see that only 1 and 2 are valid, so this has to be the 1. Now we have two digits that divide, well, one of them dividing the other, without using 1, 2, and 3. You can see that the only option is 4 and 8. Well, you need to have a digit and at least its double. So the smaller is at least 4. So the bigger is at least 8. And you see that this is the only option. Well, the number surrounded 1 can be anything because 1 always gives a remainder of 0. And let's move on to this, I think. Yes. If you're looking for a digit with 4 ones on its row, you can see that only 2 and 7 apply. So that's a 7. This is finally a 5, and that's a 7. And on this row, those must be 3, 6, and 9. So the digits that surround 7, there again, looking at the table, they must be 2, 3, 6, and 8. So 2 is not here, and 3 is not here. And now those digits must be from 1, 4, and 5. And here we get a 1, 4, 5 triple, so that has to be 8. And we know that 5 is one of them, so 5 can't be here, and actually it was really known right from the start with this 0 clue that 5 didn't belong in this domino. So there is a 5 here, so this is now 9, that's a 5. And with a remainder of 0, that has to be a 1. All right. And actually 1 did not belong here because there was a remainder of 1. And, well, I'm seeing nothing else at this point, so this is not 8. Those are from 2, 3, and 6. We need a 1 somewhere in here, but 1 does not belong in a domino with a remainder other than zeros. The 1 is here. So 3, 6, 8, and 4. There has to be a 4 here. And this 4, and that's interesting because the 4 with a remainder of 1 would be with a 3, a 5, or a 9, but 3 and 9 are taken, so the 4 is somewhere with the 5, and we know here that 5 is not here. So 4 and 5 are in here. This is from 3, 6, and 8. We need a 7 somewhere here. 7 would work with 6 or 8, all 3 actually. There's a 6 here, so that's not a 6. Those are from 2, 8, and 7. 2 would work with the 3, 7 would work with everyone, and 8 would work with no one. So that's not an 8. I think it's time to move on to this. We could note that with the remainder of 1, this is, well, basically any odd digit except for 1. So this is from 3, 5, 7. This is from 3, 5, and 9. And with the remainder of 2, this also has to be, this has to be an odd digit, I think. Yes, an even digit would have a could never have a remainder of 2. That should be obvious. So this is also an odd digit. An odd digit with a 3, this is from 5, 7, and 9, but 7 is not allowed here. But 9 doesn't work. 9 with a 2 would only be a 7. So 9 is not available for this. So that's a 5. 9 doesn't work, so that's a 3. That's the 7. That's not 3. So now this is 8. So the remainder of 1, it can still be a 4, it can still be a 6. 1 and 9 don't work. This is from 1, 4, 6, 1, 4. Actually, it has to be the 1 because I can't put a 1 anywhere in here. And those are from 4, 6, and 9. There has to be an even digit in here. With the remainder of 3, the digits are of opposite parity, and actually I can't use this nor that. So it has to be 6 and 9. So this is 4. That's a 3. That's 2. That's 8. That's 6. This is not 8. This is 8. So that has to be the 7, and that's the 2. So it's still working at this point. I haven't broken it yet. That is a 1. So what are the options here? Let's just go full pencil marks. 3 would work with the 4. 4 would work with the 5. 5 doesn't work because of this. And 8 doesn't work with any of them. So this is 3 or 4. What is this 3? It won't be 6 and 9 because of that. It won't be 5 and 8 because of that. So it has to be 4 and 7. There's a 7 here. So this is a 3 after all. And that is a 4. And here we get 2 and 4. 2 and 4 would both work with 5 or 9, but 5 makes this a 9. That's a 5. 5 I said, but 2 and 4 both work with that. What about this 3? We know that this is not 5, 7, this is not 4, 7, sorry, 5, 8, so it has to be 6 and 9 again. So it resolves this. 6, 9 pair here, so that's a 3. Oops, what did I do? On this row, I put 3, 6, and 9, but it was 5, 6, and 9. Ooh, and actually with the 5s here, well, let's remove the 3, that had to be a 5 from a long time ago, I think. And after all of that, I wonder why I break so many puzzles. 2, 7, and 8 in here, that's not 7. So 6, 9 pair here, the remaining digits include a 1, but 1 doesn't work here or there, well, for many reasons. So that's the 1. I need 2 and 3 in here. Those are 4 and 7, there's a 4 here. This is odd. 3 or 7, but 7. What did I do here? Oh, that's it. I had selected one extra cell. So I said an odd digit, 7 doesn't work, the remainder would be 3. So that's 3, that's 2, that's 3. That's not 2. This is from 7, 8. We're left, the 4 in this column must be here. So that is 6 or 9. And here we have 2 and 3. Here, those are from 6, 7, 8. But 7 here would need the 1 there for a remainder of 0. So that's not 7. And then on this column, we have the 6, 9 pair here and the 8 there, so that can only be a 2. 8 here, 6, 7, 2, 7 and 8, that's 3, that's 2. This 2 now resolves that. This 4 resolves this. The 8 resolves that. We're left with 3 and 7 here, but either Sudoku or just this 0 cube allow us to disambiguate. This is now 6 or 9, and there has to be a way of disambiguating all of that. Oh yes, this is here. This remainder of 1 only works with the 6. So this is now done, I think. Yes, oh, there's no answer check, but I'm quite confident that this is correct. So this puzzle actually did solve pretty nicely, well, at least if you were cautious enough to take this remainder table. I did prepare that, but, well, what can you do when you just make mistakes? Well, this is the Canard conclusion of this video. Thanks for watching it, and see you soon on SudoKanard.